Hi, let's quickly review the partitive interpretation of division. I have here 20 divided by 4 and notice that 20 is a multiple of 4. By definition, 20 divided by 4 is the number of objects in each group when the complete collection of 20 objects is placed into 4 equal groups. So think of it this way. 20, say, is the number of apples we have, and we would like to put them into 4 baskets, and we would like to put the same number of apples into each of the baskets. So we're really asking our total 20 apples, we would like them to be 4 copies of what number do you think we should put in those baskets. Since we know multiplication tables, we know the whole number 5 fits in there. So 5, 5, 5, 5. So by definition, 20 divided by 4 is the number of objects you would put in each group, and that is equal to 5. And remember, 20 is called the dividend, 4 is called the divisor, 5 is called the quotient. So notice that for this definition to make sense, we really need the dividend to be a multiple of the divisor. Why is that? So 20 divided by 4 by definition is the number of objects in each group when the whole collection of 20 is placed into 4 equal groups. So such an action is only possible when the dividend is in fact a multiple of the divisor. Now we would like to talk about 3 divided by 5, but at this time we do not have a definition for 3 divided by 5. So that means we do not have a definition for this expression where the dividend is not a multiple of a divisor. So we need to give this expression a meaning. In preparation for that, let's take a look at this 20 divided by 4 on the number line. So in other words, I would like to define 20 divided by 4 in the following manner and show you that this definition also yields the same answer of 4. So I would like you to now think of 20 divided by 4 as the length. So I'll write this is the definition. 20 divided by 4 is the length of one part when a segment of length 20 is partitioned into 4 equal parts. Okay, so I'd like to now do that. So here's the number line, and notice this is a segment of length 20, and I'd like to partition it into 4 equal parts. How do I do that? That's my approximation. And what I'm now saying is, let's think of 20 divided by 4 as actually the length of each part. Since we partition this segment into 4 equal parts by length, the length of this part is the length of this part is the length of this part is the length of this part. So now we're saying 20 divided by 4. I'm defining it as the length of each part. And you will definitely agree this length is 5. And so notice that even though this looks like I'm giving a new definition, I'm redefining 20 divided by 4 or something, I'm really not. This way of thinking of 20 divided by 4 will give us the same answer as this way of thinking 20 divided by 4 in terms of, let's review this. Here we said 20 divided by 4 is the number of objects in each group when 20 is partitioned into 4 equal groups. And then we got the answer of 5. But if we think of 20 divided by 4 as the length of one part when a segment of length 20 is partitioned into 4 equal parts, it is really still talking about the same thing. This is instead of 20 objects, I now have a continuous model. I have a segment of length 20 and I'm partitioning it into 4 equal parts, and each part's length would still be the same answer of 5. So why do we want to think of it this way? Notice now I don't need to have the dividend to be multiple of the divisor. I could easily replace this 20 by 3, and I would get a length. Then this definition would still make sense. So let's discuss that in detail in another video. Thank you.